Welcome to an Azure Incident Retrospective. I'm David Steele.
And I'm Simon Kuba. We both work in the Azure Communications team.
In addition to providing a written post-incident review after major outages on the Azure platform, we also host these retrospective conversations.
You're about to watch a recording of a live stream. We invited impacted customers through Azure Service Health and Azure Service Health Alerts to participate in a live webcast featuring our relevant engineering leaders.
By joining one of our live sessions, customers and partners also had access to a Q&A experience to ask questions of our engineering experts during the event.
As you know, building reliable applications in the cloud is a shared responsibility. So this conversation includes our learnings at Microsoft, as well as guidance for our customers and partners to make their services more resilient.
We hope you enjoy the conversation that follows, and we really welcome feedback on how we can make these sessions even better. So feel free to scan the QR code below the recording for our 2.5 question survey.
Super. Today's focus incident was an event that was triggered by a power event in our West US 2 region. While we did maintain power to our data centers there, we did lose cooling capacity, and this meant that the data centers across multiple availability zones started to heat up to a point where some of the infrastructure began to shut down. As we cooled to the right temperatures, recovery then followed. However, because of some networking issues, we had an extended restoration time.
That's right. Sounds like a big deal. So to talk us through the impact, our response, and our learnings for the incident, I'd like to introduce a couple of engineering leaders joining as our guests. Joining us live in the studio, we have Idet and Posong. Idet's representing our physical networking team, and joining us live virtually, we have Navin Sethi. Navin is our general manager from the data center operations team, who's going to talk us through what this looked and felt like for the data center folks on the ground. Thank you both for being here.
Super, thank you. Navin, perhaps I can start with you. But before we get into the incident itself, and before we talk about all the steps that we're taking, power events, I feel like they're a dime a dozen when it comes to data centers. Could you talk us through what's supposed to happen when a data center experiences a power issue? What is the expected response from a data center and the data center team when these types of things happen on a good day?
Yeah.
Oh dear.
Power events are effectively handled in layers, right? The intent is to keep IT power load low powered and protected, while keeping mechanical systems available so the environment remains within effectively its thermal limits. If incoming utility power is lost or is unstable in some way, backup power systems are expected to carry the critical IT load. And the facility controls should either ride through the event or transfer the affected systems to the backup power, depending on the site design. So for IT load, in that question, the design goal is continuity first always. UPS systems, for example, will bridge those short disturbances. Generators support the extended events, and IT systems have protective mechanisms if temperature or electrical conditions become unsafe. And then from a cooling perspective, the expected behavior is that the pumps, the fans, the fluid coolers, the air handling systems continue operating or recover quickly after the disturbance clears. The cooling is critical because even when IT power stays available, loss of cooling can drive thermal shutdowns.
That's great to understand kind of both halves of that point. So we've got batteries to hold the load while generators spin up. That's what things are supposed to happen. Let's put a pin in that until we get to the story on this fateful day. Edith, I'd love to bring you in here. Same question for you, right? That this happens. What's supposed to happen once power is restored? If there's been some kind of a disturbance, what's supposed to happen? How do we do our recovery in a staged manner?
So when we have a power outage, network systems recover. We have disaster recovery playbooks. We have a prioritized order of checks. So usually we start with utility clusters, then we move to storage, then compute, and then we look at higher layers of the network. So it's usually just validating that the systems have come back online, and we communicate with our first party and external customers to validate that all systems have come up and have recovered.
Right.
That's usually what happens during a power outage.
And networking is one of the very first stages there. Nothing can talk to each other without networking.
Yes,
so
networking always is first. We're collaborating with Navin in the data center services. We're validating all the systems are back healthy on the line. Then we're actually talking to storage, right, and then to compute. And then we validate that customers have recovered and everything goes back to normal.
That sounds seamless. Shall we fast forward to the 29th of May?
Absolutely. So the 29th of May, going back to you, Navid, the trigger event for this issue was a thunderstorm, and it caused some sort of power instability on the grid. So we initially thought there was a loss of power, but we later confirmed it wasn't a loss of power, but there were sags and swells on the utility feed.
Yep.
And could you just walk us through what did the team experience on site? And it also sounds like this wasn't just a regular thunderstorm, but it was pretty significant.
Yeah, that's absolutely right, Sammy. So, yeah, look, an initial trigger, as you mentioned, was this very severe thunderstorm. And I want to paint the picture a little bit for our folks listening in and watching this. The storm occurred in the Quincy region, and local residents there have said it was one of the worst storms in 40 years. The lightning strikes that occurred through the thunderstorm caused significant damage to property across the Quincy area. There was significant tree damage and fallen trees. There was a number of fires reported as a result of the lightning strikes. And luckily, no one was injured, so that's the main thing. But the thunderstorm itself, to your question, created a really widespread utility power sag swell disturbance, right? Beginning around 9:15 p.m. Pacific time on May 28th. Early in any major incident, there's always a bit of a fog of war, right? What I mean by that is that there's teams dealing with weather conditions, we have multiple alarms, there's utility information coming in, and site telemetry pretty much all at the same time. And the initial interpretation when we were partnering with our utility providers was that there was a utility power instability. But this was actually later confirmed, as you noted, Sammy, as a sag swell, right, behavior on the utility feed. But what that means is the power quality was effectively unstable. It wasn't simply a clean, complete loss of utility power. So effectively, a sag is a short duration voltage drop, and a swell is a short duration voltage increase. Both are effectively power quality events, and they can occur when utility power is still present. So the site is experiencing this abnormal incoming voltage condition across multiple data centers in the Quincy Metro. Some of the facilities are transferred to generator power, while others remained on utility, depending on the site design and how the local infrastructure effectively responded in the moment to this power quality event. The storm was not treated as a routine weather event, effectively. It was really a broad utility instability, the high operational complexity, the safety constraints that we had for teams moving between buildings whilst there was still lightning strikes occurring across the Quincy region. All of these things had to be carefully managed. And we also had to be very careful about how we fall back. If utility conditions remain unstable, moving back to utility prematurely, it can actually create an additional risk to our services. So the team maintained effectively a conservative posture, Sammy, until those conditions were understood and stabilized.
Navin, that's great context to understand kind of the wider storm and especially that the importance of maintaining, the health and safety of people on board. Obviously, that's paramount. Now, you mentioned impact to multiple data centers here. I understand, generally speaking, availability zones are generally designed with independent power, network, and cooling. Obviously, some weather events are large enough to impact multiple zones. Now, I understand these data centers that were affected were in multiple AZs, but not all AZs. Can you just help us understand the blast radius of impact here?
Yeah, David, from an infrastructure perspective, the impact was concentrated in facilities serving two physical availability zones, AZ1 and AZ3. The utility disturbance itself was broad across the metro, but the customer impacting thermal behavior was not uniform across every facility or every AZ. So several data centers experienced the same upstream power quality disturbance at roughly the same time. But only a subset of the sites had cooling systems that entered into that protective mode in a way that reduced the available cooling capacity. And that led to this IT thermal protective action that we took. The incident, as we know, affected compute and networking storage systems because those systems depend on a stable environmental condition and not because power redundancy failed.
So, Navin, it sounds really interesting, and you touched on something to say, look, the sites responded differently, and you said part of it was by design, understanding that across 3 availability zones, lots of data centers, that we don't have a homogeneous design across all our DCs, and so some failed, some didn't. For the most part, what I'm understanding is that we were able to switch to generators where needed. And the problem ran into the cooling issue. So our power remained stable, like we handled the sags and swells, but our cooling systems shut down, question mark, by design, and that's predominantly where we saw issues. Like we managed the disturbance, but I just want to understand the trigger was really down to the cooling issues, the cooling systems shutting down.
Yes. Yes, so in this instance, Sammy, the response varied by facility, right? Some of the sites actually transferred to generator power, as you noted, others remained on utility, whilst the voltage itself was going through this sag swell that I described previously. And regardless of the power source, portions of the cooling infrastructure itself detected this abnormal electrical condition. And these variable frequency devices known as VFDs, which control the speed of the fans and the pumps, and the building automation systems known as BAS, place some equipment into a protective state. So the VFDs in this instance protect the rotating equipment, such as the pumps, fans, from unsafe electrical conditions, right? The BAS is the control layer that monitors and commands the building systems, including the cooling equipment. And in this event, some of the cooling systems did not automatically recover after the conditions stabilized. The fluid coolers, the pumps, the fans, and associated controls actually required a manual reset, or as we would call it, operator intervention, right, human intervention. And as the cooling capacity effectively dropped, the temperatures rose, right, and the IT systems engaged thermal protection, right, I've got to protect myself, control shutdowns intended to protect the hardware occurred, and that preserved the data integrity.
That's great to understand kind of what happened here. So I'd love to hear that the IT load itself didn't experience power issues. Where we needed to use batteries, use generators, it wasn't that a bunch of servers were de-energized, it was that sags and swells were enough to cause the cooling issues. And so that makes sense here, that this wasn't the generators struggled and so a bunch of servers had to shut down. The only shutdowns we're talking about here were in response to the rooms getting warm. So thank you for explaining that. I'd love to understand kind of what it was like on site for the team on that day. What did it look like to investigate and mitigate some of these challenges, but presumably with the storm still raging?
Yeah, absolutely. Look, first I've got to say, given how I described the nature of the storm and how consequential it was, once in a generation, effectively, I was so proud of the Quincy data center team because they made so many of the right decisions under intense pressure. We prioritize safety above everything else in our data centers, the safety of every personnel at the facility. And they took that same mindset in how they operated. They moved with urgency, but they didn't compromise safety at all. And as I mentioned, they were operating this whole time during an active storm, which by nature is unpredictable. And to paint a picture to our customers, these buildings are spread out geographically for some considerable distance, right? These are multiple buildings with cooling systems, as I described earlier, that effectively impact is unfolding in parallel, and our people are dealing with, a very unpredictable weather event during what is effectively a very, very difficult operating environment. So the team was responding, really on multiple fronts at once, to detect, to stabilize, to restore, to protect people at the same time. And the response really began with, monitoring and alarms, severe weather tracking in itself. What is the progression of the storm? We monitor storms through our FOC and within the data center, our facility operations center. We go through incident declaration. We join bridge calls. We provide updates to our internal engineering partners. And at the same time, we're dispatching our critical environment technicians to these affected buildings. And these teams are manually resetting cooling equipment. They're placing selected systems into hand, or what we call override where appropriate. And they're restoring fluid coolers and the VFDs that I mentioned previously, and effectively prioritizing the hottest areas first, right? So, if I break it down, it's detection, coordination, right? That's the alarms, the BAS telemetry, the work orders, our internal ticketing system, the ICM, coordinating with the bridges that we have for the data center with our engineering colleagues through our facility operations center. There's the staffing piece where we're adding additional resources to critical environment technicians and engineers in real time, late into the evening, and they're arriving rapidly at site, taking instructions, mobilizing to really drive a multi-building recovery, right? And then there's the safety aspect. The storm is still active. technician movement and access to mechanical spaces had to be managed very, very carefully, whilst there were still unpredictable lightning strikes happening. Safety and reliability were obviously the core priorities. We didn't put anybody at risk. And then we're looking at the cooling restoration itself. What teams focused on was clearing the lockouts, resetting the VFDs, the pump packages, restoring the fluid coolers, using hand override where needed, and then stabilizing those high temperature co-locations first. And then it's the IT restoration, right? Once cooling and environmental conditions are effectively stable, teams are working through the network, the rack recovery, and then including the T2s, the diagnostics, and the power cycling as well.
So, Navin, that sounds like quite the pickle you're in, where a storm rages, the
Yes.
coolers shut down by design because they're meant to shut down when they have this kind of sag swell event. Humans have to go out and kind of reinitiate this during the storm in order to get the data center back into a cooling thing. It's fascinating. And Edith, maybe this is a great time to bring you in. After Navin and his heroics team have weathered the storm and they've gone out and they've brought coolers back online after a while, now they brought the data center to a level where they say, we can safely operate now. And then they kind of hand it over to the other side of Azure and they say, bring things back online. And as we mentioned, the first thing to come back online is our networking.
Yes.
Can I hand the baton over to you to say,
Yes.
Could you talk us through the networking story? Navin has now said, okay, I think I'm done here. My work is done. I'm sure it's not Navin, but over to you. What happened from our networking side?
So in this event, the cooling issues, as Navin actually really eloquently laid out, resulted in a thermal event. And in the thermal event, the network devices actually shut themselves down to prevent hardware damage. Once the power came back, what we saw was a large number of devices auto-recovered, but some network devices had varying recovery behavior. That actually necessitated us having to lean on Navin as well to go and have data center services power cycle some of those devices to bring them back online. In addition, some of those devices that had gone offline impacted our management infrastructure. Okay. So the telemetry and visibility that we would have needed for like control and command was lost. So what that meant was the responders had to continuously identify systems that had to be brought back online. So that actually led us to actually create recovery plans that were not optimized, and they elongated the total time.
So right. Because some of those management systems were impacted, we're fighting blind. We don't have the same visibility into our dashboards of what needs to be power cycled and what doesn't.
Correct.
So what does that look like? How do you have to go out there and look to see which lights are on, and how did we troubleshoot that on the day?
So in that case, I mean, one of the things we actually did was actually worked very closely with our partners. Remember, I talked about in terms of the power scenario, we're actually identifying the critical systems for the customers. So starting with utility clusters and moving to storage. So in this case, what we're doing in those instances is, running discovery, identifying those critical systems, and then actually creating dispatch. And in this scenario where we had like a lot of issues along the way, we're actually competing also for resources to go restore those critical equipment. So that kind of elongated the time. So what happens is the engineers, the first responders, identify those systems, they give the locations to the dispatch, and the dispatch goes and actually recycles the devices and brings them back home.
Yeah. You would assume that this all just kind of magically happens in software. The idea that we need to send somebody out is fascinating.
It is, and Edith, there was a word that you said. You said some devices came on, some didn't. Some had, the symptoms, some didn't. I'm going to pull from Navin's thing. Navin was saying that not everything responded in the same way because not everything is the same across multiple campuses, multiple data centers.
Yes.
Is it the same with our networking devices? Like, I'm just trying to understand what were the attributes of the ones that came online and did what they were supposed to do versus the ones that didn't?
Right. So one of the things we should actually realize for this scenario, Navin actually talked about multiple different buildings, multiple different colos. And so we saw varying temperature profiles across the board. In the IDFs, where we actually house our spine or T2 equipment, the temperatures were much hotter in those locations. And those devices actually have a lower temperature threshold at which they trip. So in those instances, the network devices trip, but the software also maintains a latch on the power supply to prevent them from coming back up until the temperatures normalize. Because you could think about a scenario where we still have elevated temperatures and then the device just sits there and then cooks and then we result in damage, and we're not unable to bring the site back when we come back because too much equipment has been damaged. The other scenario is you can imagine where the device comes back up, temperature is still elevated, it goes back down, reboots, and you go through this continuous cycle, which ultimately still might result in damage. And so what the equipment does is maintains that latch, so it keeps the power supply down. Even though in this instance, we had power to the devices, but the latch actually maintains the PSU, power supply is down, so the equipment doesn't come back until we normalize the temperature, and then you can bring it back. So this is where we needed first to confirm with Navin's crew that temperatures had been normalized, and then to do the power cycling. So that's one of the things that elongated the recovery time.
Okay.
Well, it's helpful to understand it. I mean, it's interesting on both the data center side and the networking side. We're saying, well, that was by design. That makes sense in so many of these scenarios. Probably a good opportunity to pivot over to our learnings and repairs.
Absolutely. As we think about, I mean, so the event itself sounds extraordinary. Thank you both for walking us through it. Navin, if I could pivot to you for some of our learnings and repairs. The first thing that we said that we're going to review and enhance the process for cooling system recovery. Clearly, that played a role here to make sure that the team have clear actions to support faster recovery. And we were going to do this by June, but I'm fascinated to know, given the detailed story you told, what are the things that we can do to enhance the processes for the teams that were on site?
Yeah, absolutely. So I'll break it down. So there's a few different things. So like, I guess the question for many of our customers, look, this is a once in a generation storm, as I described it, but what if it happens again, right? It's a very fair question. There's been some significant learnings. I'll break it down that we're not looking to rely so much on the same level of human interaction and manual discovery, I would say, Sammy, right? So the short-term changes that we put in place immediately focus, as you can imagine, first of all, on some of the actions we take in real time, some of the training that we've done with our critical environment engineers, updating of our emergency operating procedures, our EOPs, more definitive recovery paths, right, where we have these oscillation of power and these line-up lockout conditions, right? That gives our operators a faster, more consistent playbook under significant stress, right? It's very hard by design to naturally recreate these type of environments in tabletop exercises, but as everything, we're a learning organization. And so we look to learn from how, we can apply some of the things that we saw through this storm, not only in the Quincy location, but in other locations around the US. And we share this learning across all our regions, both in the US and globally. So near term, Sammy, we have the lineup, lockout in an override condition effectively, right? And that's being monitored 24/7 to prevent any reoccurrence. We've updated our EOPs, as I mentioned. We've completed the training. We've improved our cooling recovery procedures. So all of these were the short-term actions that we've already put in place. Longer term, we're undertaking a complete engineering review, and we're looking how we implement our BAS, our control logic changes that would effectively reduce dependency on manual recovery and overall, Sammy, improve the fault-tolerant behavior in our data centers.
Right. Yeah, it's interesting to understand, that there are things we can do, both in terms of the people and the systems and how they respond, and the investigation's never over. Like you say, you're still running kind of more of that review. Edith, same question for you. I know the post-incident review mentioned that the networking team you're addressing some of these platform limitations that constrained storage recovery, but also mentioned some of these tooling and processes that are used to identify what infrastructure needs what. Can you talk us through some of the learnings or specific repairs that the networking team is taking on board?
Yeah, so one of a key focus here, learning from this event, the thermal event, now we're focusing recovery, orchestration, and visibility at scale. And that's the key focus for us. And one of the first things we're going to do is we have created a topology-aware map, and that allows us to identify the dependencies. And then it also allows us to create automated recovery action lists. And what we're also doing is guided workflows. From this thermal event, now we actually know those network devices that exhibit the thermal shutdown characteristic behavior that actually need intervention. Mm-hmm. So in the event that we have that globally, we can apply that to every site. So that's prioritized for our first responders. And we also learned from the management infrastructure that impacted our visibility, because you can talk about automated systems, but if we can't get the telemetry, the automated systems are not very useful. And so we've learned from maybe the thermal shutdown. We know the characteristics of those devices. We've also learned from the management infrastructure, and we're going to focus on those. And in collaboration with Navin's team, we would actually look to bring those two critical systems back first. And this is what I'm talking about, the guided workflow. And then once we do that, then the topology map and the automated recovery actions continually will just automatically feed out a recovery list so that the personnel do not actually need to do that interrogation to identify systems. We'll also align that with the storage, compute, the most critical systems, the ones that actually bring recovery for our customers faster. And so that's kind of what I'm talking about in this guided workflow. So rather than actually reason about it at the time, we partner with Navin to identify those things, bring the visibility, and then guide responders to bring up services much quicker.
Ida, I have a follow-up question. I know, typically speaking, whenever there's been a major outage, and one of the things that we love to do is to say we can always look retrospectively and say we get signals and monitoring. One of the things I'm always mindful of is during a storm, there's people on the roof. Any event is very impactful for our customers, and so impactful for the teams who are on call and not even on call at Microsoft. Is more telemetry, more alerting, does that dilute our signal to noise ratio? Do you think that these signals will be helpful, or do we think if we open that door, unwanted alerts come in that can distract engineers during a heated event?
So that's a very good question. One of the things that we had in this event, we had no shortage of telemetry alarms, right. I think when we did a retrospective, we're actually trying to put ourselves in the view of the first responder. What was happening is we have this element of fog of war, as Navin talks about. There's recovery going on to the data center, and then we have the first responders for the networking, and then the other engineering teams. The thing that we actually need is a recovery view. We don't need a lot of telemetry. We need telemetry that actually focuses on, this is what I call a topology-aware recovery view. And that just tells you the elements that are down and tells you the health of those elements. Because one of the things we didn't talk about is because of these elevated temperatures, we did see damage to some equipment. Okay. And so being able to just focus them on a recovery view, what's down, and then actually identify things that are unhealthy, we find that that's actually much better. So it's not the alarms, not the signals, but just that focus on what's down, and that prioritized list in terms of the utility, management infrastructure, storage, and then we just go through. And then being able to create that and share it with Navin's team in real time is another thing that's actually going to improve things.
It's fascinating. I think that discipline requires immense focus, because there's such a desire to grab as much information as we can. We're humans, we love information,
yes.
But it's a discipline to say, I want to filter all this out and I'm going to focus on this piece. It's a tough one to do, and so it's great that you're taking on that task.
And one of the things we want to do as well, just to help as well, is periodically output that down list. And so that everyone has a shared view. Like sometimes you come on the bridge, as you said, we're looking at so much telemetry, but if we can actually bring focus and we periodically emit data that actually shows the down list, then it allows the teams to actually focus not on the signals, but focus on recovery.
That's good.
And that's great to understand that the learnings and repairs from a data center perspective, but from a networking perspective. I know, Sammy, we've covered a lot of the learnings from Microsoft. Our post-incident review includes learnings for customers as well in terms of customer resilience. I mean, is this a suggestion of not putting all your eggs in one basket? What can customers do?
It's really tough. Typically speaking, we don't see a storm that hits such a broad area that it hits availability zones. And while zones weren't the silver bullet here, and there are times when we sit down and we say there's been an event, but anyone using zones was fine, this wasn't the case here. I don't think that in general it means that zones are a bad idea. I really don't. I think zones are the way to go. I do think they offer an incredible level of resilience. When we speak to customers, we say zones are great. If you have depending on the criticality, you want to make sure you're investing correctly in your resiliency measures. And sometimes zones is great, and other times you might want to think about some sort of region failover or region pairing. So it depends on criticality. It depends on investment and risk. If something sinks an entire state, then of course we're running into issues. But we look at probabilities, we look at risk matrices, as customers do as well. And I go back to, I always advocate for zones, but I do understand if someone's running air traffic control, they might want to think about a multi-region active-active kind of configuration.
Sure, yeah, that's a good learning. And how did we do from a customer communications perspective during the event? We've mentioned fog of war a bunch. How were we able to keep customers up to date, or do we have any learnings from communications?
Fog of war plays a role. So when it came to communications, we have our brain system. Our brain system is our automated system that communicates automatically to customers. Typically within 15 minutes, it communicates directly to their impacted subscription, so they know kind of what's impacted. And brain fired, and one of the attributes of brain, it's a wonderful tool for getting an early signal out. The problem is it can be very noisy. We speak about the signal to noise ratio, it can be very noisy. So lots of services have onboarded to brain, typically around just under 80% of outages, all up are communicated via brain. But when compute is firing and storage is firing and web app is firing and SQL is firing, and all of them have onboarded to this brain system, and so customers are getting multiple alerts, we decided to communicate to everybody in the region, everyone in West US too. Although not everybody was impacted, impact was broad enough that we communicated to everybody. During this fog of war, and we have teams that are sitting on the bridge and getting information as well. And I think at points in time when Navin would have announced, hey, we think that we're going to be cooled and restored in an hour. We took that information and we shared it with customers. And playing a game of telephone, what got shared with customers that the incident will be mitigated within the hour, which was not true, because once the data center is cooled, then we hand it over to Edith and team, and then even after Edith says I'm good, then storage takes some time, and so all of those things. So we declared a mitigation time too early. Now, as regrettable as it is, it's still a principle that we believe in, to say we want to share everything we know. It was unfortunate that we got it wrong in terms of the information, but I stand by the idea to say we want to be more transparent and wrong than opaque and correct. We as we near towards the end, we told customers restoration was looking fine. We initially got a preliminary PIR out within 3 days to share what we knew so far. We initially said, again, it was a power event, and we tried to correct that. And then 14 days, we got the final PIR out, thanks to all the contributions from Navin and Edith and team as well. So, yeah.
Got it, yeah, so that might have been noisy for customers to receive all those different tracking IDs, but it came from a good place of wanting to let them know all the different services
Absolutely, yeah.
impacted. Well, thank you. Thank you for answering that, and thank you to Navin for joining us remotely. Thank you, Edith, for joining us here in the studio. Thank you for watching another Azure Incident Retrospective. If this was your first time joining us, or you're interested in hearing about Azure Incident Communications generally, we're just going to run through some quick fundamentals here. Sammy and I are both from our Azure Communications team. We exist to tell our customers what's going on. We're not part of marketing. We're not part of our customer support team. We're really just the conduit between our various engineering teams involved on call during issues in explaining what's going on.
Absolutely. When we think about outages, we tend not to think of our competitors as being other cloud providers. We tend to think of our competitor in this sense being on-premises, because when customers have an outage on-premises, they typically know what's going on, they get updates, their leadership's involved. And so we've developed our communications philosophy in 5 areas that try and bridge that gap between on-premises and cloud. The first one is around speed. We need to tell customers quickly what's going on. The main area of this is with our AI ops. We call it Brain internally, and Brain can tell impacted customers what's going on within about 10 or 12 minutes to those impacted subscriptions. Typically speaking, we have about 70-80% coverage of our outages are onboarded into Brain, and we're constantly working to onboard more. The next one is around accuracy or granularity. It's really important that customers understand which of their resources are impacted. Telling customers that virtual machines in East US are impacted is not as helpful as telling them which of their virtual machines are impacted, and this is accessed through resource health. The third one is around discoverability. It's common practice that customers go to our public status page to look for incidents that impact them, when in reality, 99+% of the time, we speak to impacted customers through the portal in Azure Service Health. Customers are able to configure service health alerts that plug into PagerDuty, OpsGenie, and so on. The fourth one is around parity. Not only parity of our hundreds of services across Azure to ensure that they behave and respond in the same way, but parity across our Microsoft cloud. We understand how important it is to have a continuous and predictable practice across all the cloud products that Microsoft offers. And the last one is around transparency. During an outage, we try and tell our customers exactly what we know in real time, time. And again, you've just witnessed an Azure Incident Retrospective where we believe that the transparent approach in understanding what happened is a key ingredient for building trust. All of those principles and philosophies can be captured in Azure Service Health, where customers can understand which of their resources are impacted, get those brain alerts firing to their subscriptions, set up service health alerts, and get invites to Azure Incident Retrospectives along with post-incident reviews following an outage.
That's right. That's how we kind of think about our comms philosophy. To apply it in practice, I'll run through a quick anatomy of an outage, how you would expect to interact with communications before, during, and after an outage. So before an outage, it's really important, as Sammy mentioned, to configure that last mile delivery through Azure Service Health Alerts to tell the right people in your organization in the right way and in the right tools that make sense for them. Secondly, there's a lot of other monitoring that exists within Azure. You can configure Azure Resource Health Alerts if you want to know about every blip and pause that happens on a specific resource. We've got scheduled events to surface things within the VM, as well as a full suite of Azure Monitor to look at everything you could possibly want to observe about things that are going on with your Azure services here. We'll also touch invariably in these live stream sessions to talk about availability zones, site recovery, Chaos Studio for fault injection, storage redundancy options, all of these different features and services that you can take advantage of to build resilience into your applications and into your workloads on Azure. And lastly, beyond the specific architectural elements, we've got a bunch of guidance that's available through our docs and learn pages to talk about the cloud adoption framework to help your organization adopt the cloud, and even the well-architected framework to look specifically at individual workloads, including how you can make those more reliable. Lots of resource-specific guidance and advisor. This is just a small number of things that you can have a look at to help kind of remediate and improve your resilience gaps.
Wonderful. So now that customers have done those things before an outage, we fast forward to during an outage, what's happening. Now, myself and the team, we're interested in building systems that scale. We understand that in order for us to tell millions of customers around the world what's happening with their resources, we have to build systems that scale. And so one of the ways we do this is by investing in areas where we democratize information. And what that means is whether you spend $1 billion a year on Azure or $1 a year on Azure, we're going to tell people the same thing. We also want to tell them in the same source of truth as well, which is why we rally around single sources of truth, both internally and externally as well. In addition, during an outage, we want to tell you not only what's going on that we know and have confirmed, but at times things that we don't know. We're still ruling out a change. We're still looking at data center. Something doesn't make sense. This mitigation was attempted and failed. We want to tell our customers everything that we know so that they can make decisions and how they do this. Now, during an outage, many customers raise support tickets, and sometimes that's a great idea, and other times it's not so. It's not the best use of time. It makes sense to open a support ticket when if you've set up an Azure site recovery, as David mentioned, and you need help failing over, that's a great time to leverage our technical support team. If you're just raising a support ticket to confirm that the impact that you're seeing matches the symptoms that you're reading in Azure Service Health or the public Azure status page, that's not a great use of your time or the use of the time from our tech support agents as well. A lot of the time, David and I get questions around how does Microsoft respond to outages? How does Azure respond to outages? And generally speaking, we have about 3 categories. The first one is we kind of call them expected outages. We expect VMs to blip. We expect them to go down from time to time. It's not common practice. We have a multiple line SLA, but we do expect these things to happen. When this does happen, we respond appropriately. The ones that we kind of call unexpected is when we might lose an entire zone, and we might see multiple servers impacted in that zone. And typically speaking, we have a response profile for that. But really, really where things get unacceptable, and we kind of call it whoa, and it's a bit egregious, is when there's multi-zone or multi-region impact. This is really hard for customers to architect against. And so as a response profile to this, in addition to publishing a post-incident review within 14 days, we also try and get something out within 3 days so that customers know what we know so far. But also this is when we run the incidents like we've just had now with an Azure Incident Retrospective, so you can hear directly from our leaders what happened and navigate some of the complexity. And it's a great opportunity to ask our SMEs questions in real time about how the issue impacted your own environment and some of the steps that you can take perhaps to be resilient to those types of things.
That's right. So mileage varies depending on what kind of outage we're talking about here. We're starting to get into a little bit this after outage world. And as we pivot around to our learnings and our post-incident reviews, we really want to be quite intentional about how we learn from incidents and how we talk about that learning. That's why we try to resist the urge to talk about a root cause. We're not looking for one thing that went wrong. With massive distributed systems, we're looking for all of the different contributing factors that had to line up for customers to experience the impact they did. We want to learn from all of those. So we're not just looking for one thing. We also try to resist framing anything as human error, right? If a human or an operator made a mistake, that's a signal to us that our systems didn't provide that operator with the right intelligence, or that our systems lack the right safeguards to prevent that person from being able to cause customer impact. In a similar vein, we want to resist blaming the person at the keyboard. We know that we can't fire our way to become more reliable, and actually we want to encourage this culture of people to speak up when something bad is happening. Our engineers, and especially our leaders, need to know that we want to have a blameless retrospective and rally around trying to improve the situation as quickly as possible. We want to resist "I told you so," but as we've talked about a little bit in this session, customers have a role to play in the shared responsibility model, and so we want to use outages as a way to educate customers about decisions and trade-offs, about the different resilient services that you could use to try to have something be less impactful for you next time that it happens. We want to resist the urge to reassure customers an incident won't happen again. We always talk about what could we do to make this kind of thing less likely or less impactful, but it's inherently, it's probabilistic here. Sometimes outages look really similar, but actually involve very different failure modes. And lastly, we want to resist the urge to tell the perfect story. Our outages aren't TED Talks. They don't start with once upon a time and end with they all lived happily ever after. We actually want to embrace ambiguity and encourage everybody to have a conversation about topics that we don't have the answers for, and where we're still trying to figure out the right path forward or the right way to improve things. That's a really important part of the story. We don't want to gloss over that. So across all of these different areas, we really want to make sure that we're learning from incidents in quite an intentional way, and this is how we show up to you in the Azure Incident Retrospectives when we have these conversations with our engineering leaders. A couple of links on screen here to make sure that you have access to our previous recordings, as well as a way to get invited to future sessions. So thank you for joining us for this incident retrospective, and we hope you learned a little bit more about how incident communications works on the Azure platform. Thank you.